name's Samir, and I've been looking at generative adversarial networks, the arms race of machine learning. World War II was one of the largest arms races in history, and we had a lot of technological advances in that time. We had countries from both sides, the Axis and the Allies, trying to create the largest and most powerful weapons. So the US started with a Jeep, and they're like, yeah, we got a Jeep. And then Germany says, well, we have a tank. And we also have a bigger tank. And then US is like, well, we have a boat. And then Japan says, we got a bigger boat. And then the US did this. But the point here is that the arms race allowed us to build some of the world's most powerful weapons, and that's the nuclear weapon. So what would happen if you put two machine learning models, the neural network, that is based off the human brain, against each other? And that's GANs. So today I'm going to be talking about my own GAN that I built, how they work, and their applications. So let's start with my GAN. So this is the code I have. So on the left, you'll see the code for the first neural network, that is the inverse convolutional neural net. And on the right, you'll see a convolutional neural net. And these both train in this section and work against each other in an arms race of their own to generate new images from scratch. So these are the real samples it was given. It was given as a reference so it can learn how to make new images. And this is the first result I got. It just looks like noise. So as we progressively move on, we get better and better. They look less grainy. They look more realistic, more clear. And these are the final fake samples versus the real samples. And you might actually mistake one of the samples on the left as a real image. So how does it learn? So it starts off with a generator neural network. It generates images. And then there's a discriminator neural network that classifies images. So the generator takes a 100-dimensional vector and generates a new image. And the discriminator will look at real samples and use that as a reference to classify whether the generator's images are real or fake. If it classifies it as fake, the generator has done its job wrong, and it iterates until it can actually fool the discriminator. If you didn't catch that the first time, I'm going to use an analogy. So there's a criminal, and he has a bill, and he's trying to forge it. And he gives it to the detective, and the detective says, well, this bill is clearly wrong. This is what you've done wrong. I can't accept this bill, so take it back. The criminal takes it back, iterates, tries to fix what's going on, and then gives it back. And then this keeps going until it's able to fool the detective. So what are some applications of GANs? We've been able to do stuff like feature arithmetic. We've taken faces. So we've taken a man with glasses, subtracted a man without glasses, and then we added a woman without glasses to get a woman with glasses. And so it's pretty cool to see how you can do feature arithmetic with GANs. And we've been able to create new art. And arguably, I'd say it's better than Pablo Picasso or Leonardo da Vinci, just with computers. This is, I think, the best application yet. We've been able to generate new Pokemon. It's so cool. But seriously, it's so amazing to see that we take a data set and we actually can make variations of that. So we've made new Pokemon. Then we've also done super resolution. We've taken images that are low resolution, and then we've used a GAN to pick up the features of that image and make it more clear. We've also done stuff like style transfer. We can take a picture of a horse and add a pattern of a zebra on it, like this, or over here. We can also take an apple and make it look like an orange. So that's pretty cool. We've also done where we take hand-drawn images and convert it to whatever the GAN feels like it putting. So as you can see, the hand-drawn image is of a human, and there's a really badly made human on the right. So we've also been doing text-to-image, which is really interesting. Using natural language processing, we're able to find the positions and objects in a sentence and create new images based on that. And this is the real application that I think is going to be the most impactful in our day. We can create new drugs that have never existed before in such a short time. So the possibilities are endless. Yann LeCun, the director of Facebook AI and a computer vision legend, said that generative adversarial nets is the most interesting idea in machine learning in the past 10 years. And I completely agree. Who knows, we might have our own personalized cartoons generated just for us, or we might cure hereditary diseases with drugs developed by GANs. GANs take us one step closer to artificial general intelligence because it allows us to add creativity to AI. Thank you.